These notes are for section 5.3 in the trigonometry unit, and it's for trigonometric functions of any angle. This is a really important aspect of trigonometry, and I don't expect everybody to understand everything the first time you see it, but like everything else, the more you see something and the more familiar you get with it, the easier it should get. So first of all, with circles, with angles, we talked about drawing angles in standard position. And when we drew angles in standard position, we always started on a coordinate plane. So if I start, this is going to be your X and your Y. And the quadrants that we drew these in, we always started at the positive X axis, and that's quadrant 1. A counterclockwise angle was positive, so if you started here and you moved along, you would then go to quadrant 2, and you keep coming around. This would be quadrant 3, and you'd end up in quadrant 4, and you can continue to go in all those quadrants. The quadrants are Roman numerals, and I want you to get in the habit of using Roman numerals. Don't use numeric numbers. I know when I'm typing when I'm writing correcting your papers, it's hard for me to do the Roman numerals, so I usually use numerical, just basic regular numbers, but I want you to get in the habit of using Roman numerals. The important part in this section about the quadrants is that if an angle is drawn in a specific quadrant, it's got a point where it ends up. And if you're in the first quadrant, the X is positive and the Y is positive. In the second quadrant, the X is negative and the Y is positive. In the third quadrant, you go left, so X is negative, and you go down, so Y is negative. And if you're in the fourth quadrant, you're going to go right, so it's positive X, and then you're going to go down, so it's a negative Y. That's going to be the basis for a lot of what we're doing right here. And I'm not going to show you everything in these notes. You really need to watch the live lessons for me to explain the examples to you in detail. Okay, the other aspect of this, which is going to take some getting used to, is that trigonometric functions of any angle. If I were to draw an angle in a coordinate plane, the sine is going to be the ratio of the y value over the radius. So if I wanted to give you an example, say I'm going to draw this angle that looks like this. I can make a triangle, and what happens, this becomes my X, this becomes my Y, and this is my radius. So if this is my angle here, theta, sine of theta is going to be opposite over hypotenuse. That's where the y over r comes from. Cosecant is just the reciprocal of sine. So I flip it in r over y. If I were taking the cosine of theta, cosine is going to be adjacent over hypotenuse, so x over r. Secant is the reciprocal of cosine, so r over x. And my tangent of theta is my opposite over my adjacent, so y over x. And so this is what we're going to use to find ratios. So the first thing I like to teach, the book does not teach it in this order, but I like to teach with reference angles because it's going to help you understand what's going on. A reference angle is always acute and is always going to be positive. So for example, if I draw an angle in the first quadrant, this is my angle theta. The reference angle has to be acute. Well, this is acute, so that's good. And it's positive. Well, this is positive. So this is going to be theta prime. Theta and theta prime are exactly the same thing if it's in the first quadrant. if it's in the second quadrant. So this is my angle theta. Well, now I have a problem because that's not acute. So I'm going to make another angle to make this acute. I'm going to start from the terminal side and go to the x-axis. This will be theta prime. So for example, if theta were equal to 140 degrees, 140 gets me to here, but I want to get to the x-axis. I'm going to say theta prime is equal to 40 degrees. Notice it's an acute angle and it is positive. If I had something in the third quadrant, so the angle that I've drawn in blue is theta, I want to get an acute angle. Well, I'm not going to do like I did this one and continue that angle on, because theta prime always has to use the x-axis. I'm going to use that angle, theta prime. So it's got to use the x-axis. So if theta were equal to 200 degrees, this blue is the 200 degrees, theta prime is basically my distance from the x-axis to that terminal side. So it's going to be 20 degrees. Then if I go to the fourth quadrant, this is my angle theta. Theta prime is going to be positive. It's going to go to the x-axis. So for example, if theta were equal to 340 degrees, the blue is 340 degrees, I'd have to get to the x-axis, and the shortest distance to that x-axis is going to be 20 degrees. And it works also if you have negative angles. I'll give you one example. So if I had a negative angle here, let's say that's negative 135 degrees. The positive direction is going to go that, and is closest to the x-axis. So that means theta prime is going to be this distance here. This distance is 180 degrees minus 135 degrees. So it's 45 degrees. I'll give you one example, but then I really encourage that you go ahead and watch the live lesson when I show this. Let's say I have a point 1,4, and it's the terminal side of an angle. So if I drew this point 1, 4, it goes right here. And that's going to be the terminal side of this angle. Well, I need a right triangle to understand this better. So I'm going to create a right triangle. That means this distance here is 1. This distance here is 4. And I want to find sine, cosine, tangent, cosecant, secant, cotangent. So I need my radius. So r squared is equal to 1 squared plus 4 squared, which is equal to 17. So r is going to equal the square root of 17. So sine of theta is going to be the opposite over the hypotenuse. Then you've got to rationalize the denominator, and it equals 4 squares of 17 over 17. If you go back to here, that's what I was showing you in this case, y divided by r. So y divided by r. 4 divided by the square root of 17. And I would continue, and I could find every single one of these. Cosecant is a reciprocal of this. So the square root of 17 over 4. Cosine of theta is going to be x over r, so 1 over the square root of 17. Rationalize the denominator. Secant of theta is the reciprocal of cosine, so it's going to be square root of 17 over 1. And tangent of theta is going to equal y over x, so 4 over 1 reduces to 4. Cotangent of theta is equal to 1 over 4. And that's why we need reference angles. If I drew this in another quadrant, say I used the point 1, -4. Here's the point 1, -4. Here's the angle I'm talking about here. But I need a reference angle to make this triangle. This is my reference angle. And then I have to be very careful. This is a +1, this is a -4, and that's going to change the values.